We're going to talk about naming acids. And this is the last group of things we're going to learn how to name. We will study acids more later, but basically acids are molecular compounds that form ions when they're dissolved in water. They form ions, and yet they're not ionic compounds. And so they're going to have a whole special class of names just for themselves. We can recognize acids in their formulas because the hydrogen will be first. So you look at the first element. If it's hydrogen, bang, you know it's an acid. If the first element is a metal, done, you know it's ionic. If the first element is a nonmetal other than hydrogen, then you have to look a little bit more. If you've got two nonmetals, it's a molecular compound. If you've got more than two nonmetals, hopefully those first two are NH4, and it is an ionic compound. We recognize acids from their names because their names always have the word acid in them. How easy is that, right? Hydrochloric acid. Is that an acid? Yes, I think it is. Acids fall into two categories. Not super happy with how your book does this. Talks about binary acids, those containing hydrogen and a nonmetal, and oxyacids, those containing hydrogen, a nonmetal, and oxygen. I prefer to think of them as the oxyacids and the other acids. So here we have oxyacids. These have oxygen. These acids do not have oxygen. The problem with the book's definition is that there's an acid, HCN, that falls into the rules of the binary acid naming, and yet this has 3 elements in it. And so that bothers me. But that's the only exception. So let's look at the binary acids or the other acids first. So 2 elements, except for that one. And these names have this pattern. Hydro, the base name of the nonmetal, whatever element it is. Now we're going to change the ending to ic instead of ide. And then we're going to put the word acid at the end. So HCl. This is starting with hydrogen. So we're going to look at this. We've got 2 elements. There's no oxygen. Chlorine becomes chloric, and we put the prefix hydro in front. We've got hydrochloric acid. HBr, hydrobromic acid, from bromine's name. And just so you're aware, why am I putting AQ here? AQ means aqueous, means that compound is dissolved in water. When you put HCl in water, it is an acid, it forms hydrogen ions. But if you have pure HCl, it's actually a gas, and it's a molecular compound, and it would be named hydrogen chloride or hydrogen monochloride. So again, I'm not going to try to trip you up on that, but I just want to tell you about it so you know why AQ keeps showing up after things. So if we look at this guy, H2S, starts with H, it's an acid. Sulfur is the base name, so this becomes sulfuric. Now, why did they keep the UR? I don't know. They just did. Sulfur and phosphorus, the end parts of their names kind of come and go. We don't keep the UR if we make it sulfate, but here it's sulfuric instead of sulfic. So this is hydrosulfuric acid. Why are there 2 hydrogens? Because sulfur, when it's an ion, forms a 2- ion. Hydrogen is in group 1A, forms a +1 ion. We need 2 hydrogens to balance the charge on the sulfur. Acids are molecular compounds, but you put them in water and they form ions. So we can predict their formulas based on the charge of the ions that they form when they're put into water. So what's the name of HF? Hydrofluoric. Hydrofluoric acid. So notice there's no flour in fluorine. It's UO, not OU. That's a real common misspelling, no flour. It's gluten-free. What would the name of H2SE be? Hydro, and that's selenium, right? So hydroselenic acid. We change the ending of selenium to ic. And again, if you keep an extra letter or two or throw away too many, I'm not going to get on you about that. The other group of acids, which there's more of, are the oxyacids. These contain oxygen. They have oxyanions from that table of polyatomic ions in them. If we look at HNO3, if we cover up the H, there's NO3, that's nitrate ion. H2SO4, cover up the H's. I'm sorry, H2SO3. SO3, find it in the table, sulfite. H2SO4, that's got the sulfate ion. So these are named from the name of the polyatomic oxyanion that they contain. And you figure that out just by covering up the hydrogens, see what's left, find it in the table. The number of hydrogens that are going to be associated with it will depend on the charge. So sulfate has a 2- charge. And so we need 2 hydrogen ions. If you had phosphate with a -3 charge, you need 3 hydrogens. Nitrate has a -1 charge, you only need 1 hydrogen. So the oxyacid names are based on the oxyanion name, nitrate or sulfite or whatever. So if the ending of the oxyanion is "ite," then we change it to "us." So nitrite becomes nitrous acid. If it ends in "ate," we change the ending to "ic." So let's look at this table from your book. There's a mistake. It says H2, C2H3O2. There shouldn't be a 2 there. So if we look at these, HNO2, so cover up the H, NO2. NO2 is nitrite. We change the "ite" to "us." So we have "ite" and "ic." I'm sorry, we have "us" and "ic", we have "ite" and "ate", and we have to figure out how they go together. That's one of those things that there's so many of. So there's a silly sentence. Rick ate him before he could bite us. You might say, well, that's cannibalism or something. Well, it could be, I don't know, a cow. He ate the cow before he could bite us. I don't know. I don't even know where this sentence came from. Ick and ate go together. Rick ate, ick ate. Ite and us go together. So the sentence helps you to pair these two things. So ite, nitrite, becomes nitrous acid. Nitrate, ate and ick go together, becomes nitric acid. And that is the pattern for all of these oxyanions. There is no hydro prefix in front of any of these. If it's got oxygen in it, we do not use the prefix hydro. That's only for the ones that do not have oxygen. Any questions? Well, I ended up talking about this one a lot. let's just be daring and do something else. We'll not do that. How about HClO? Well, cover up the H. What's the name of that ion? Hypochlorite, right? Hypochlorite. So what I'm going to do is I'm going to get rid of the ite and change it to what? Us. Bite us. Chlorus. Hypochlorous acid. Let's do a different one here too. How about H3PO4? What's the name of that? And you can maximize your guessing. That's got phosphorus in it. So it's probably going to be phosphate or phosphite or something like that, right? It's phosphate. So that has phosphate in it. So 8 goes to what? Ick. Rick 8. Ick 8 go together. So I'm going to get rid of the 8. And here's where the OR in phosphorus comes back again. I don't know why. Maybe because it sounds better. Phosphoric acid. So that's phosphoric acid. Any questions? This is a flow chart for those of you who like flow charts. The key to naming things is to identify, is it ionic, is it molecular, or is it an acid? Because you have to use the right type of names. Students like the molecular names, and they tend to want to use it for everything. You can only use it if there's 2 nonmetals. And then this gives you an example of how to use the flow chart. If you like that kind of stuff, you can go over that.